Welcome to a new test and teardown video. Look what just came in. The Twintex PPM-5H07. So this is a power supply, yeah, but not an ordinary power supply. It's a linear power supply and it's brand new. So I'm a little bit excited about, not that excited. I'm a little bit excited about playing with new stuff for my lab. But as you can see here, it's a 500 volt, 350 watts, 0.7 amp. And it is just fantastic. This is how you turn it on, and it's got a lot of really cool features. So now it is on the floor. I don't know if you can see this, but it is quite big, full of screws, and that must be a big, heavy transformer. Let's try and put it on my scale. Okay, so it's just under 11 kilos. Looking at the Twintex web page, they explain about the different models exist in a TFT and LCD version. The so-called manual only covers the LCD version for the model that I got. If you look at the pictures here, they're shown for the low voltage but high current version and also the switch mode version. What I got is the linear version. It's quite classic when you deal with Chinese companies. There's a price and then you negotiate and then you ask for this and this for that and so on. So that was the first answer I got, the $550 for the LCD version, or $695 for the TFT version, and then $145 for shipment. But the real cost was shipping $165, and then bank charges $43 on top of that. So all in all, it was $903 including shipment, and they ended sending it with a truck all the way from China to Denmark, believe it or not. Let's look a little bit in the manual I got sent prior to receiving my product. And it got a 1 millivolt of resolution and 0.1 milliamp of set point resolution. This is the linear version. And on the next page, they say a lot about all its features, and all that is very impressive. And of course, this manual was not updated to fit the TFT version. And then we can continue to see the different front layout. So this is the current output that is less than 10 amps. It's using banana plugs. And if we look at the high amp version, that is low voltage but high amps, more than 10 amps output, then they got these really big strong screw terminals. So I kind of like that for high current. And then we look at the different variants of linear, switching, TFT or LCD versions. Of course, you will see here the voltage ripple is a lot lower on the linear, and this is exactly why I chose the linear version. Yeah, it is very heavy and all that, but for my experiments it's much more important to have a nice, clean and quiet output. In the manual, they say a lot about the display and the control panel, how to control the different features and all that kind of stuff. And it is very similar between the LCD version and the TFT version. You can see the layout here of all the numbers and text and all that kind of stuff. It is very similar. This model here, or all their power supplies in this entire series, got timing output. So that means you can set up different times and different voltages and all those different settings of all the parameters for a lot of timing setups like this. And the cool thing about Twintex is that you can set the loops to continue forever. And this is something I really miss on my Siglent power supplies, on all the other power supplies I got of programmable power supplies. They can't do repeat forever. This is absolutely great. The Twintex can do that. Also, it got a battery charge capabilities where you can set the different curves of different technologies. If you're experimenting with battery charging, of course, this power supply can do all that as well. And then in the last pages of the manual, we'll see the power ranges, voltage currents, and all that kind of stuff for this model. And the fun thing is that the PPH, the TFT version, is not mentioned down here in the model section, but I just wanted to show you a summary of all the specifications for this model in case you wanted to see it. And the last page in the manual also says a little bit about additional features like interface and so on. I didn't get software with it. It also says something about some software should be included or being available. They should be able to remote control this one. That has not been provided so far. So here's my voltage. You select the different menus here, and then you can just write 1, 2, 3, poof, and then you get 1, 2, 3 volts. It's that simple. I totally like it. What I really think is fantastic is this. This is what I need for some of my tube experiments. So here's 500 volts, and then I can just set a current. Oh, I can also do like that. If I, oops, can I do? Okay, so I need to do 0.1 minus 1. Why are you doing that? 0 point. Okay, so there's a little bug in the software. I don't know if you see that. Did you see that? Let's try and do that again. Okay. What is that? So that is probably not correct, right? Am I going to screw this? What if I do this and just say enter? Okay, so it goes red. Okay, so that is 0. At least that is nice. You can set the output current to 0, and it's of course gonna go to 0. So 0.1. Thank you. And then it's gonna go on again, obviously. Oh, by the way, you want to see how you can how you can lock this up? There is of course some bugs. I've been playing around with this a whole day here before I started to make this video here. So utility. Ooh, we got all sorts of settings. Let me go a little bit closer here. System. More time. You see here? There's a time here. And it's year, month, date, hour, whatever kind of thing here, right? It's a little bit funny. So why do we have year, month? Okay, date. So that should be the day. Or what, right? I don't know. What if I click something here? But you want to see something funny? This is the year, right? I guess today we are 2023, right? So how do I go on? How do I proceed? Oh, by the way, there is no manual for this product. You need to figure everything out yourselves. There are only specifications and all that kind of stuff. Of course, they give you specifications, and all that is fantastic. But I haven't figured out how to do this. If I go like that, no, but I can go. Okay, so I can go back like that. But what you would expect is to enter here, right? Or you would expect to go to something else. Ooh, no. So I didn't store it, right? So how do I store the year 2023? I would expect to hit enter. If I do that, see, we have a lockup. You can't click anything. It's not responding. Hello. We have a dead end. So I can't proceed with that. Obviously, what you want the date to work. If you use the USB stick and you store the data on your USB drive and all that kind of stuff. So the only thing you can do is to perform a power cycle. Oh man, that's how it is. And the default setting was, by the way, it goes beepity 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 beep every time you click something, and you could of course turn that off in the utility. We got some other pretty cool features with graphs and all that kind of stuff. So I kind of like that as well. You can also go into that mode that way, and you can also regulate for power. Let's try and play a little bit. So here's 100 volts. I got 6 bulbs, and this is my little tester, 3D printed, of course. So you can easily homemade stuff like that, right? So here is the thing, that the 3 sockets up here, they go to those 2 sockets, and the 3 bulbs down here goes here. So that makes me able to put those bulbs in series, and they're very nice and visual for high voltage, high power loading, and they're a lot cheaper for the watts compared to electronic loads. And my electronic loads don't really do a lot of high voltage and high power at the same time and all that kind of stuff. So I kind of like this, and it's also super nice and visual. So anyway, 100 volts is like that, and we want to crank up the amps, right? And let's go back to voltage. So that was 100. Oh, now we're gonna go bright. So that is 400 volts, but we can go as high as 450, right? So that should be equivalent to the normal voltage on those bulbs, because they're in series, right? And I did, of course, mix 60 watts and 40 watts bulbs like this. So I have an equal voltage over them all. But here we go. That is quite close to the maximum potential of this power supply. It should be 350. So I should probably go and find some other bulbs. Oh man, this is getting bright here. So, but the current, I'm very close to the maximum current. So that means I can't really do a lot more, right? So output power is 302, and input power is 420. Okay, 430. So that is an efficiency of 70%. Really? For a linear power supply, that is amazing. So I can't wait to open and have a look. They have done some pre-regulation or some fancy smart stuff, and I've been playing with this for a couple of days now, and I haven't heard its fan turn on yet. So I don't know, what are they doing? Some smart tricks? Wow, let's just enjoy this for a second. So this is where your 11 kilograms goes. Wow, this is some beast of a power supply. I've been looking a little bit more on everything here, and I think I kind of figured out how this works. If you look under all the transistors, I don't know if I can get some light in there, but you will find big capacitors and a lot of resistors and stuff. And it's the same, stop that. And it's the same at the other end. No, they even permanent mark art. This one for 500 volts, and I see another little mark on the PCB down there. But have a look down there. Bridges. So in this side, we'll find 4 rectifier bridges. Yeah, maybe you can see them now. It's difficult to show this because there's a tiny, tiny little hole down there, right? 4 rectifier bridges, and those goes to, of course, all the 4 different capacitors and each individual transistor. And they're, of course, in series. And it's the same over here. But here I can only find 3 bridges. I don't know exactly where the last one is, but there's probably also a 4th somewhere, right? So I believe all those transistors there are in series. And that explains how it can really work, because look at that, the transistors there, MJ 150 volts, 50 amp, NPN transistors, and this is exactly the same with all of them, right? And then all the outputs there combined, we got a sense resistor, we got bleeder discharge for the output, we got a little output capacitor bank, and that will be the output wires that go straight out to the output, right? Oh yeah, let's look here at the front. If we look in here, I will probably see if I can go there, but this is the display, and all the switches and stuff, they're connected to a PCB down there. But I don't know if that is easy to see, but there's actually 2 circuit boards here. So it's really packed with electronics. Can you imagine that? A whole board on the front, and then one more again. And all those cables and goodie stuff down there. So there's a CPU down there. We got some DA converters and all that kind of stuff. The build quality is very, very high and impressive. Everything is done exactly like how you would have done it. And you see, yeah, you see all the rectifiers down here. It's quite clear with all those resistors, and you see a reverse diode per step. And there's no relays at all. So I bet this is how it works with all the different outputs. Oh yeah, look at this little circuit up here. And the thin black wires, they're temperature sensors. Somebody changed this IC, and the 2 white wires, the secondary here, goes to a little bridge and capacitor, regulator transistor that drives the fan. And all those wires, they are connected to temperature sensors, one in each side of the series regulators, and one that goes under here and inside the main transformer. So, and this board is not connected to anything at all. This is just a little standalone temperature regulator board. I'm a little bit disappointed to see there's no feedback wires to the software that could potentially say the temperature or tell, oh, you're close to getting too hot or something like that. But there is no such thing. But I found something else. Here is one of those mechanical temperature switches, and it's in overprotection circuit. That one, let me see if I can, yes, that one, good. And that one is just an on-off type of temperature protection, and that goes, of course, to this board, and that will go back to the software. So that means you have all your output, and then suddenly you have nothing. So that is all there is to it, but at least there is some sort of a temperature kind of feedback, right? If we look at the transformer secondary windings, isn't it just amazing? All those outputs, we are talking about 12 individual output windings on this power transformer. 12 outputs. And of course we got the 2 individual 110 volt primary windings, and they go down to this voltage selector switch, and that is accessible via the backside, the bottom side of the case, and all this is located neatly around the mains on-off switch, and all that is of course completely perfectly nice and fine. So now we are behind the screen, and look at that. There's another processor here that is handling display and switches and all that kind of stuff, and output filter, and protective earth is yellow. Here I would like to try and explain to you the topology of this linear power supply. So first let's start with something very simple. Let's imagine we have a transformer here to the left, a bridge rectifier and a capacitor. So here's where we have stored 100 volts. And then we have a linear NPN transistors. This is our voltage regulator. This is the business end of 99% of all linear power supplies, right? And of course we have an output capacitor, output load resistor for stability and all that, and of course a reverse diode. And let's imagine this transistor is in linear mode. We can regulate this using an op-amp, local feedbacks, and all those kinds of things that makes this a DC voltage supply, okay? So this first one here is from 0 to 83 volts. This is of course about 1/6 of the output. We got 6 transistors in this power supply. So I just imagine for this example that the linear one is 0 to 83. Okay. Let's look at this one. So I have scaled this up. I only show 4 sections out of 6 just for simplicity, and it's easier for you to see what's going on. And let's imagine the first one, the bottom one is the linear one, right? And now if you want an output voltage between 0 and 80 volts or something like that, you have all the other 3 turned off. So that means your output voltage will just go straight through the reverse diodes of all the others. So they are not adding to your loss budget, okay? And if you want more and more and more, you simply turn on more and more of the other outputs. So they are either fully on or fully off. That means in either case, they don't contribute to linear drop out, and there's no power loss, or it's really low. Of course, you got the diodes in the rectifier, and you got the diodes in each stage. But this explains exactly what they have done in this power supply. They have 6 sections of voltage they can switch on and off, or I mean 5 of them can switch, and the last one is the linear regulator. And then of course you have a global feedback to some op-amps and all that kind of stuff, doing voltage and current feedbacks and whatnot. So I just wanted to explain a little bit about the topology that I found in this fantastic power supply. And the cool thing about this, there isn't any moving parts. There is no relays and such. So that is why I really like this. I think it's going to last for a long time compared to relays. So that was the end of this video. Thank you very much. See you soon. Bye bye.